Hey there guys, I'm going to talk about piecewise functions today. A piecewise function is one that uses different functions over different sections of the domain. So usually what we see, we'd say something like f of x equals, and then there'd be one function, one formula given a certain domain, and then another function or formula given another part of domain. So kind of like this here, where we have f of x equals 4 if x is less than or equal to negative 2, or f of x equals x plus 2 if x is between negative 2 and 1, and f of x equals 2x plus 1 if x is greater than 1. And so over different parts of the domain, the function will have different properties. So if the values we're plugging in are less than or equal to negative 2, then we'll use this function. If the values we're plugging in are between negative 2 and 1, we'll use this function. If the values that we're plugging in are greater than 1, we'll use this function. So the graph often looks like it has different shapes making it up. So one thing we can do is to kind of break the domain into different chunks. So looking at those pieces, so that's where we're starting. It's the same problem here. So identify the section of the graph for that'll describe each part of the function. And so if I'm just looking at where is x less than negative 2, and so so negative 2 here is when x is negative 2, it's that part to the left, whereas x between negative 2 and 1, which would be this part here of the function, and then whereas x greater than 1, which would be in this part of the function. So each space will have its own graph. So one of the reasons we talked about needing to know the parent functions was for doing this type of thing, that when I'm drawing this, or especially when I'm looking at graphs of these, which is something we're going to kind of get ourselves into trouble. So, but what I want to think about here with this function, so f of x equals 4 if x is less than or equal to negative 2. So what does the graph of f of x equals 4 look like? I remember another way to say that is that y equals 4. Well, those y equals lines are our horizontal lines. So this portion of the graph will be a horizontal line. Now, what portion of the graph are we talking about? We're talking about the portion that's less than or equal to negative 2. Well, we know when we graph inequalities that when we have equal to, we get a closed dot. So that's something to think about later. But essentially what we're going to be doing is taking this value that we're being shown here. Okay, so negative 2, that's going to be our x value. And then what's our f of x value, right? Well, what this is saying is that no matter what x values we choose, the y answer will always be 4. Right? Well, what x values are we allowed to choose? We're only allowed to choose the x values that are less than or equal to negative 2. So negative 2, negative 3, negative 4. And whenever I plug those in, I always get 4 as my answer. And because this isn't equal to, this particular point will be a closed dot, that end dot. So we're going to go to negative 2, 4, and make a big closed dot. So make that one obvious. And the other one should just be little points. So negative 3, 4, negative 4, 4, right? And it's going to keep going to the left forever. So that part of the graph is going to look like a straight horizontal line heading off to the left. Then I want to make a table for the middle one. And so what I'm going to do is I'm going to pick x values that fall in this domain. Now what's kind of weird is that even though it says x has to be greater than negative 2, we're still going to put a point at negative 2. And then I'm going to also have a point here at the end, so 1. I'm going to pick numbers between them, so like negative 1 and 0. And so it says f of x is equal to x plus 2. So I'm going to take these x values and add 2 to them. So negative 2 plus 2 is 0, negative 1 plus 2 is 1, negative 0 plus 2 is 2, 1 plus 2 is 3. Now, this is just a greater than, so what that means is it's going to get open dot. So at negative 2, 0, I'm going to put an open dot. So open circle. And this, because that's an equals to, it's going to get a closed dot. So at 1, 3, I'm going to put a big closed dot again. Those are the only ones that should be obvious. The end points should be obvious. And then the middle ones, negative 1, 1, just little dots, 0, 2, just little dots. And then, again, this is a line, right? This would be, the slope would be 1, the y-intercept would be 2. I know it's a line because the exponent is a 1 here, so this is just a graph of a line. Draw a line between those two endpoints. All right, and then the last one, again, think about what I was just talking about. You know, this is going to be a line again because, again, the exponent here is 1, so it's going to be a linear function. What I'm going to do is grab this x value and start my chart. So starting at 1, even though it says it has to be greater than 1, I'm still starting at 1. And I'm picking numbers that are greater than 1, like 2, 3, 4. There's not really a set number of points you need to have here for these. Just more is better. And it says that f of x is equal to negative 2x plus 1. So negative 2 times 1 is negative 2, plus 1 would be negative 1. Negative 2 times 2 is negative 4, plus 1 would be negative 3. Negative 2 plus 3 times 3 is negative 6, plus 1 would be negative 5. Negative 2 times 4 is negative 8, plus 1 would be negative 7. Since this here is an equal to, or not an equal to, it gets an open dot. So 1, negative 1 gets an open dot. And then 2, negative 3, just a little point. 3, negative 5, little point. 4, negative 7, little point. So as I draw this, this will be a line. Again, like I said, it's going to have an arrow on the end of it, since it is going off to the right forever. Right? It's saying it's every number bigger than 1. So it's going to keep going to the right forever. The first graph had an arrow off to the left because it was every number less than negative 2, so it kept going less than negative 2 forever. This one had, no arrows here because it was between two numbers, so it had endpoints on both ends. So you can see how each piece of the graph lives in its own little chunk of the domain. A couple of things to notice. Notice how that I have a closed dot here and an open dot here, right? But they don't overlap. Like, they're right on top of each other, but this red graph does not come over the blue graph at all. Okay, that never happens in a piecewise function. They don't overlap like that. They can meet at one particular point, or they could have a big gap between them, but they never would overlap each other. You would never also have a closed dot here and a closed dot here, because then that would not be a function. Okay? We could have an open dot here and an open dot here, but we couldn't have two closed dots because then the vertical line test would be failed. But I can have a closed dot here and an open dot, or that doesn't have to be in any particular order of them. Just one can have an open dot, one can have a closed dot. Little things like that to pay attention to. Let's see. Yep, that's about it. We're drawing it piecewise. Let's try it again. So just going to take a kind of look at what I'm drawing here. So I have an x cubed, right? What does x cubed look like? That is that vertical S. So when we're done drawing, we should have a piece like that. Then we have negative 2. Right? So just a number, which means we're looking at just a horizontal line. And then the last one here, square root, that was that half curve off to the right. So it started at 0, 0, and half curved off to the right. So kind of think about that. So what I like to do is use charts. So what are my x values I'm allowed to use? What's the function going to be equal to? So again, you always start with the number that they give you, even if it's a greater than or less than, but no equal to. You always start with that number because that's where the dot goes, the open circle, the closed circle goes. So starting with negative 1, and I'm allowed to use numbers that are less than negative 1, so like negative 2, negative 3, stuff like that, and negative 4. Okay. Well, since this is a cube function, I'm not going to be able to use very many of these. Negative 1 cubed is negative 1, negative 2 cubed is negative 8, negative 3 cubed is negative 27, and negative 4 cubed is negative 64. So I'm only going to plot a couple of these, Again, since this is not an equal to, that gets an open dot, open circle. So -1, -1, I get a big open circle, and then -2, 8, -8, I get 2, 4, 6, 8, like just a point. So now I should be drawing this full graph like this, but we're not seeing this whole thing, right? That'd be what x cubed would look like. But we're not going to see all of that because only part of the domain is being used. Right? Only the values where x is less than -1 are being used. So only that piece of the graph is being used. With -2, that should just be a horizontal line through -2. So I should be drawing this. All right, that's what the graph of -2 looked like. But we're only going to see part of it because only this part of the graph is in the domain. Okay, where's the domain that's being used? -1 to 4. Oops, I didn't quite erase enough of it, but so shouldn't see that part either. Okay, so I don't erase my graph. I want to do it the right way. So the idea is that if x, now what's f of x? So what x values am I allowed to use? So always pick the endpoints, so -1 and 4, and then you can pick a couple points between. But it's a horizontal line, you really don't need much information. When I plug in -1, I get -2 as my answer. When I plug in 0, I get -2 as my answer. When I plug in 4, I get -2 as my answer. But I want those endpoints, so -1 is the equal to, so that means it's closed. And 4 is the not equal to, so that means it's open. So -1, -2, I'm going to big closed dot. At 4, -2, I'm going to do open dot. So make sure those are obvious, and then I'm going to connect those with a horizontal line. So it should be obvious at the ends what if it's a closed dot or open dot. And last one, the square root part of the function, so x, f of x. So what values am I allowed to use? Numbers that are 4 and bigger, so 4, 5, 6. So I want to square root 4, which of course is 2. Square root 5, square root 6. Should be using numbers that are easy to square root, like 9. So square root of 9 is 3. And then this isn't equal to, so that means that this is going to be a closed dot on this end. And this is where the arrow is going to be because it's going to keep going right forever. So 4, 2, I'm going to make a nice big closed dot. And then 9, 3, I'm going to make just a little point. So this one's supposed to look like this, where it starts at 0, 0, goes through 1, 1, curves off to the right like that. But we're not going to see that part of the graph because it's not in the domain. So we should just have a little arrow here at the right end. Nice big obvious closed dot at the left end. So again, notice how the graph doesn't overlap, right? It doesn't come across the blue graph, they just meet at the endpoints. Again, there can also be a gap between them, and sometimes you see that, but I don't think we will. There could be a gap between them. But they don't overlap. We should have one closed dot and one open dot, or we could have 2 open dots. Never have 2 closed dots here. And they don't overlap, one closed and one open, not 2 closed. Okay. So that's how you make a piecewise function. That's one way. The other way is, I've seen people do it, is where they do draw the whole function and then erase the parts that that shouldn't be there. I don't like doing that because they can overlap, and then you end up erasing one part that you need when you're trying to erase another part. So I don't really like that method. What you guys are going to be doing is going to be basically, we're going to be given a function, and you're going to have to pick it out based off the graph too. So when we're looking at the graphs, if we don't know the shapes of the parent function, so I'll show you guys how to do that. So given a certain piecewise function, can you identify which graph it goes to? So definitely things I would be looking for to make this easier are looking at the domain pieces that they give you. Right, so it's based on everything around 1. So what I would notice here as I look at the graphs, that these 2 endpoints are here at -1. So it definitely can't be that one. So it'd be an easy one to pay attention to. Get rid of any that are obviously, the rest all have the open dot's at 1, so, or enclosed dot's at 1. So next thing I would pay attention to is the type of function we're looking at here. So this is a linear function since the exponent is 1, and so that's going to be some graph of a line, right? It has a positive slope, so we should see a line like that. And this other one is an x cubed, right, which is that vertical s. So we should be looking for graphs that have those pieces here, right? And so here I see a line. Here I see that part of that s. Here I see a line. Now this is hard to tell, but this is actually part of the s. It's just this part over here that's pretty straight up because it is very steep. So here we've seen that. Same thing. There's the part of the s and then part of a line. Now these two are very similar. I think one more often things they do too is if they switch the domain. So like this is saying the line should be on the numbers that are to the left of 1, and the x cubed should be the numbers to the right of 1. When I look at this graph here, I notice that the x cubed is on the left side, not on the right side. So, and the line is on the right side, not on the left side. So this also can't be. They've switched the sides on the function. So it's supposed to be the line on the left and the cube on the right, but this one had the line on the right and the cube on the left. So we see that both of these have a line on the left and the cubed part of the function on the right. So that's not anything we can pick apart here. And the lines look the same, as far as the slope. Has a slope of 1, right? It's rising, it's rising 1 and running 1, rising 1, running 1. It also has a y-intercept of 1, which is what this was supposed to have. Right? So thinking about the slope and the y-intercept, right? The slope is 1, y-intercept is 1. Here, how do you know that is a cube function? So here we see a point at 1, 1, right? 1 cubed is 1. And we see the next one at 2, 8. So 2 cubed is 8, so we can see that it is a cubed function. So it looks like the only difference between these two graphs is which one has the open circle, which one has the closed circle. So here the line has the open circle, so that should be the not equal to. And the cube has the closed circle, so it should be the equal to. And here we see the line has the closed, so it should be the equal to, and the cube has the open, so it should be the not equal to. So let's see what it's supposed to be. So the cube is supposed to have the equals, or has the equals. That means it should have the closed dot. The line does not have an equals, so it should have an open dot, which means this would not be ours. So this would be the one we would choose. If that was C or whatever, we would pick that one. Let's try that again. I think the easiest thing again to start off with is looking at the values here. These are at 2. So anything that doesn't have open circles and closed circles at 2, I would chuck out right away. So this graph has them at 4, so that's gone. And this graph has them at -2, so that's gone. And then probably what I would do again next would be to see like which one's left and which one's right. So here absolute value, what does absolute value look like? Absolute value is a V, right? And then this one is 1, right? That's a horizontal line. So I should see a horizontal line and a V. So, which on both of these we do see a V part and a horizontal line part. So that's definitely not anything that we can worry about. Absolute value should be on the less than, which is the left side. So here we're seeing the absolute value on the left side. Okay, so that's something on that. And the horizontal line should be on the right side because that's the greater than. So here we're seeing that. And so that's not going to be a differentiator for us. And so then we get the circles, right? They're opposite here. So this one, the absolute value has the open, which means it should be not equal to. Absolute value is not equal to. The line has the closed, which should be equal to, which this one does, right? So looks like this, would not be ours. So maybe B would be our answer here. So let's use some process of elimination to help you guys do these. That's what I recommend. Last thing you want to do is evaluate an absolute value function for given values, right? So what's f of -1, what's f of 0, what's f of 2, what's f of 4. So what that absolutely does not mean is that you plug each of these numbers into both parts of the function. Right? Remember, the function this part of the function only works if the x values are less than 2, and this part of the function only works if the x values are greater than or equal to 2. So any of these values that are less than 2, I would plug into the top of this function. Any values that are greater than or equal to 2, I would plug into the bottom of this function. So just be paying attention to that. So f of -1, -1 is less than 2, so that would go into this. F of 0, 0 is less than 2, so that would go into the same one. F of 2, well, 2 is equal to 2, so that's going to go into here, and 4 is greater than 2, of course, so that's going to go into there again. So all I have to do is say, well, f of negative 1, and then we're using the top of it, so negative 1 squared minus 2. Negative 1 squared is 1 minus 2, which is 1. So f of negative 1 equals negative 1 again. Then f of 0. Well, 0 squared minus 2. That would be 0 minus 2, which is negative 2. So f of 0 equals negative 2. And then f of 2. Well, that goes in the bottom part of the function. So 4 plus the absolute value of 2 minus 5, which is 4 plus the absolute value of negative 3, which is 4 plus 3. So f of 2 equals 7. And then f of 4, so 4 plus the absolute value of 4 plus, minus 5. So that's 4 plus the absolute value of negative 1, which is 4 plus 1. So f of 4 equals 5. So again, just make sure you're plugging the value into the right part of the function. Do not plug negative 1 into both parts and get 2 values. And plug 0 into both parts and get 2 values. All right? You're saying, okay, negative 1 is less than 2, so that goes in here. 4 is greater than or equal to 2, so it goes in here. Try it one more time. So the first one here, f of negative 3. Alright, so negative 3, so f of negative 3. So negative 3, so I'm looking over here. Negative 3 is less than or equal to negative 1, so that's going to go to the top of the function. So negative 2 times negative 3 squared plus 3. So make sure you're following PEMDAS. We're going to square first. So negative 2 and negative 3 squared is 9 plus 3, which would be negative 18 plus 3, which is negative 15. And then I'm going to go to negative 2. Negative 2 is less than or equal to negative 1. So f of negative 2 equals negative 2 times negative 2 squared plus 3. Got too close there. Again, follow PEMDAS, so we square first. So negative 2 times negative 2 squared, which is 4, plus 3, which is negative 8, plus 3, which is negative 5. So f of negative 2 equals negative 5. And then I go to negative 1. Negative 1 is less than or equal to negative 1, so it's also going to go into the first part of the function. So f of negative 1. Negative 2 times negative 1 squared plus 3. Negative 2, so negative 1 squared is 1 plus 3, which is negative 2 plus 3, which is 1. So f of negative 1 equals 1. And the last one, f of 0. So 0 is greater than negative 1, so that means it's going to go into the bottom part of the function. So f of 0 equals 5 times 0 minus 7, which is 0 minus 7, which is negative 7. So f of 0 equals negative 7. Alright, should be pretty easy, just matching graphs to functions and then doing some evaluating. Again, main thing with evaluating is that making sure you're not plugging each number into both parts of the function, but just into the part of the function that it actually belongs to. So check the domain. So negative 3 is less than negative 1, so it goes into the first one. Right? Or here, negative 2, if I was using this one, it would go into here because that's the equal to negative 2, so it'll go into that part. If I was plugging negative 2 into this one, negative 2 is greater than negative 3, so it would go into the bottom part here. So just make sure you're checking the domain to see which part gets used, and that should be pretty easy. Take care.